Today in Geometry, Chapter 4, Section 4, we are going to prove triangles congruent by using the side angle side, which is the SAS, okay, side angle side, and the hypotenuse leg theorem. Okay, the last lesson we learned to prove two triangles congruent using side, SSS, and today we're learning two more theorems. Okay, for the side angle side, we have to have two sides of a triangle and its included angle. Okay, that's very important. The included angle is very important. So if we had that side RS is congruent to side XY, and we had that side RT is congruent to side XZ, then we would have to have that included angle in there. The included angle is the angle that is the vertex of those two sides, where the two sides come together. Extremely important. So in triangle RST, we're talking about angle R, and in triangle XYZ, we're talking about angle X. Okay, we couldn't use T because it is not the included angle. We couldn't use S because it's not the included angle. Okay, it is the side, it's the angle where those two sides come together. Okay, here's RT, here is RS, and so it's the angle that brings those together. Okay, on XYZ, here is XZ, here is XY, and here is the angle that brings them together, that included angle. That's very important. The second theorem that we are going to look at is the HL, or the hypotenuse leg theorem. All right, the first thing that we know is that the word hypotenuse, okay, the word hypotenuse is used only with a right triangle because it is a side that is opposite a right triangle. So this theorem can be used only for a right triangle. Okay, if we can get a hypotenuse in one congruent to the hypotenuse in the other, and either leg congruent to the other leg, then we can prove that those two triangles are congruent. Okay, it's very important that we have the hypotenuse though, and again, it can only be used on a right triangle. Let's look at an example where we will use the side angle side to prove two triangles are congruent. Okay, we're going to do a two-column proof. Here's our column for our statements. The second column is for our reasons. Okay, the very first thing we are going to put is the given, that segment BC is congruent to segment DA. Okay, all right, we have that right there. That gives us one side congruent to a side. The second given that we have is that BC is parallel to AD. Okay, BC is parallel to AD. Now, that's our reason for that is that it is given, but we're going to have to go back to the previous chapter to review that in our mind so that we can see how that's going to help us. All right, if we know that BC is parallel to AD and it's cut by this transversal, then what do we know from that? We know that alternate interior angles are congruent. So we have that angle BCA has to be congruent to angle DAC. That gives us an angle congruent to another angle. What is the reason we can say that? Because alternate interior angles are congruent. That gives us one side congruent to one side and one angle congruent to another angle. Now we need the third side. So we can use side AC is congruent to AC for using the reflexive property. Okay, so that gives us our third side. So we have one side right here, AD, congruent to BC. We have this angle right here, DAC, congruent to BCA. That gives us, that's an included angle. And AC is congruent to AC. So we have side angle side. So we have that within the body of our proof. So we can go ahead and say that the two triangles are congruent. Triangle ABC is congruent to triangle CDA. And why can we say that? Because of the side angle side postulate. And again, side angle side, okay, is over here. We have put it in the body of our proof, so we can use that. So for a quiz, I would know that side angle side, SAS, is a way to prove But the triangles are congruent. Okay, SAS stands for side angle side. I would know that we also learned that HL means hypotenuse leg, and that a hypotenuse only exists if there's a right triangle, so we're going to use HL when we have a right triangle. And that the postulate that we used before this lesson was SSS, okay, which means side, side, side. That those are the three postulates that we've learned so far to prove two triangles are congruent. That's what I would know for a quiz. Okay, these three things right here, I would know for sure. Okay, y'all have a very good day and have a pretty good idea that you need to know those three things.